Gene Jones. I'm with an organization called the Southern Waste Information Exchange. We're a small nonprofit organization that assists industry and municipalities with waste issues. We also do a number of tasks for various regulatory agencies, mainly the Florida Department of Environmental Protection here in Florida. This particular webinar we're doing today really came to me after seeing an article on Brontech's mobile technology and EPS densification technology. So I thought it would be time to talk about this issue again. We're always stressing about market development for recyclable materials, and this certainly falls in line with being able to process this typically a problematic waste stream, and we'll go into a little bit of detail about that today. But I just wanted to share with you, I guess, the technology that's in the marketplace and is developed, and this one particularly caught my eye because I think it has applicability to a number of different areas throughout the country. If you allow me, let me start by just going over a little bit of admin things. I am putting people on mute as they come in. We are recording the webinar itself, and at the end, the conclusion, I'll wrap up those video recordings and get them out to everybody along with the PowerPoint and PDF format to everybody. We're at the end of our presentations. I'm going to start it off and give a quick little intro to kind of show our background in the area of densification of expanded polystyrene. And then we're going to move over to our featured speaker, who is really going to be talking about the mobile aspects of it. When we get to the Q&A portion of it, we will try to go through the unmute process. If we can do that in a manageable way, otherwise I'll just leave it on the chat function and we can ask questions that way and I'll read them. Real quickly, our introduction into this entire process, the way it happened for SWIX, is our first experience in this was through an innovative grant that we got through the Department of Environmental Protection back in 2008, where we put in a collection program here in the state of Florida, down in Polk County. We had 4 very large expanded polystyrene producers. 3 of them were what we call block manufacturers. So you had Insulfoam, Carpenter, and Master Container. And between that and public supermarkets down in that area, those 4 companies generated 5,000 pounds of expanded polystyrene per day. And the bulk of that film, or material, I should say, not film, but that material was going to the landfill. So as part of our grant process, we found a facility that we could put in some equipment and started receiving the waste products that were coming in. These were typically off spec, in cuts, that sort of thing that end up going into a landfill. We had bags of waste that we brought in. You can see the amount and the volume of material that came in. We first started off with this piece of equipment. It was a Hager densification unit, and it would be able to output roughly 220 to 440 pounds per hour. So we've got a pretty good compression ratio. And this particular unit, as you can see in here, we basically has a shredder and then a compaction unit, where we were creating these logs, if you will. And so those logs were then stockpiled and typically put on pallets and shrink wrapped where we would make it available. We realized as we got into this, because of the volume of material that we were bringing in as part of the process, that we needed more equipment. The first thing we did was to bring in this bag house collection facilities to where we were grinding the material, and then through gravity fed was going into the densification unit here. But still, this unit still wasn't able to keep up. So we ended up working with another company called Reusable, and they're out of New Jersey. And Reusable brought in this densification technology that you're going to see a little bit from what Brian's going to talk about, where it basically, through this shredder, would blow up into again, a gravity-fed hopper down into the densification unit, where it's a thermal process. So shredder again blowing up through this blower back up into the gravity-fed unit. And this is where the densification technology, this is where it really takes place. It's a thermal process that heats up the expanded polystyrene, and then through that process, you go through a molten phase where you're then able to, the way that they were doing it in this case was just basically take a pallet and then weave the material that was coming out. Now, it's pretty hot material. So you definitely had to wear some gloves that, you know, thermally protect yourself, but they were basically weaving that material onto this pallet to where they can then make it economical for transportation. Wrap it up or put it in these super sacks, and you can see the weight. You know, you're getting 1,400 pounds per bag. That made the economics work out. From there, these are the compressed through the Hager technology, where we were, you know, stockpiling the material again to make it economical for shipping. And the bulk of this material was going off to end manufacturers that were typically making molding that you might see in Home Depot. There is a demand for this material. It does have relatively good market value to it. So it does make sense if you can work out the economics to be able to bring in the equipment to densify it and then get it into the hands of somebody that can use it. Just results from that particular little program that we worked with, we roughly recycled almost 1.3 million pounds during the grant period from that project. And we saved over $262,000 in avoided disposal costs from the for the generators for that material. So we proved the point it can be done. And to that point, what ended up happening, this actually project ended, and the generators ended up getting their own densification equipment. So I think all of them, with the exception of Publix, has densification equipment in place in their operations where they're densifying their material and then marketing that end product. As another result from this project, we worked to, through another innovative grant, to get that type of technology through, I think it was 12 to 13 facilities here in the state, typically municipalities, where we put in that densification equipment. Now, I don't know whether that equipment is still operational around the state. I know a couple of counties have gotten rid of the equipment over the years. But it does show, when we talk about market development, these are the types of projects that I personally believe in and think that other states should be doing more of this to try to enhance the recyclability of materials, as opposed to, you know, having that material going into a landfill. I'm now going to turn it over to Brian Ohnemus, who's the president of Brotech. And again, I saw Brian's equipment, I think it was in an article. And what caught my eye about it is it's mobile, right? And so with that, Brian, I'm going to turn it over to you. You just tell me when to advance the slides for you, and maybe give a little bit of background in terms of how you get started in this, and how you develop the equipment and what successes you're having around the country right now.
Sure. No, thank you, Gene. I'm glad to be here. If you want to flip to the next one, I think that kind of starts covering, that's a little bit of who I am. I've been in the EPS industry a long time. Started out years ago engineering, designing the molds and working on the presses. Took over the plant manager position of the companies you alluded to down there are the same type companies that I worked for. These are major players. In the facility I ran, we utilized 500,000 pounds of raw materials a month. So after years of doing that and looking at the volume that our facility alone was landfilling, in 2016, I started on this mission with the concept of I can build a more efficient densifier system than what's available to the public now. So you want a slider,
Yes, sir.
please? All right, and as Gene started going through the slide before, these are the challenges that when you're wanting to begin a program to recycle EPS or styrofoam, everybody calls it. These are the main hurdles. The first one is the capital. You know, a lot of this equipment, and I'll say is at the low end, 50,000 and then on up. So you got to come up with the capital to purchase the equipment, the facility, the staff, the overhead. And traditional stationary units like you just saw offer limited access. So they have a certain mile range that people are willing to travel to bring the material there for recycling. So you have to locate the outlets then, if you're the owner of the equipment, what do we do with it once it's densified? And then you got to educate everybody in the area that the equipment's online and ready for service. So these are all challenges from day one. And typically, because I talk to a lot of communities, the main hurdle is coming up with the capital and the facility and all the overhead that goes with having a facility. So my system is set out to address that. Next, please. So I offer it in two different directions. Let me go a little bit of what the mobile densifier does. To process polystyrene in a reasonably high density, which is what you want to get the max weight for shipping, it requires heat and pressure. So, you know, if you put one in a facility, they're typically three-phase. There's a significant expense to get the units in and set up and operating. So what I did is took a small combustion motor. In this case, I run 8 horsepower Honda motors, so they're very small, very fuel efficient. And I designed a process where I could reclaim the heat, the natural heat coming off of the exhaust. So the motor drives the shredders, just like a traditional unit. But whereas they have a series of electric heat elements to generate the heat, I'm simply recapturing the wasted heat coming off the motor. And what that ends up achieving is if my RPM runs my temperature, and you'll run into various densities. There's, you know, from a 1 pound density to a 3 pound density, they all run completely different in the equipment. And when I'm talking density, I'm just talking about how dense the foam is. You have, say, dunnage, which is the really light stuff for inexpensive products, or the high density, which is usually like a pharmaceutical cooler or something of that. They're very heavy, very thick. So I can simply adjust the throttle to adjust the throughput speed and the densifier head temperature. That's how I achieve mobility on it. So I need no outside source of energy. I pull up, hit the key, the thing starts. It takes me about 3 to 4 minutes to get it to temperature, and then you can just start feeding through it. But I wanted to go one step further and offer in 2 different scenarios. As I kind of alluded to this before, there's a learning curve to running a recycling facility or an operation of any kind. You got to get some tribal knowledge on what the material is. You're going to run into multiple different materials that are not polystyrene. So there's a learning curve to that. So if the people want their own unit, so-and-so county wants a densifier, I can set them up with that mobile densifier. The one you see on open, that's a demo unit that I want people to walk around and be able to see it. Traditionally, you'll put that inside a trailer so you're not fighting the elements going from stop to stop. But then the objective is to eliminate the buildings, eliminate a fixed structure, eliminate all that overhead. Let's take this to the foam versus everybody having to bring their foam to a centralized location. And by building this technology, it's much more cost efficient from original purchase to capital expenditure, but then you don't have any other overhead that goes with it. So we've had enough interest that a couple months ago we launched what we call the Styro America Recycle Service. So what this is designed to do, if your city, if your county doesn't want to take on a recycling program of their own to handle this stuff, we'll come in and do it. So we can take one unit and service multiple locations versus multiple communities all having to buy their own units. We can be here for a couple of days. We can be, 60 miles away tomorrow processing in another town. And typically, that'll cost less than a cup of coffee. It's less than $1 a year for a resident. So from a cost standpoint, and I guess headache standpoint, it's much more feasible to utilize the service over even buying the equipment. And don't get me wrong, I'm here to sell the equipment, but there's a lot of applications where the service model would work better for a community. Next, please. Yeah, now I'm just getting in a little more of a comparison here between the two. Of course, the Styro Hybrid, the mobile densifiers, you purchase a unit, you can put it in a trailer, you have to train your staff. We help on that as much as you can train somebody from a remote standpoint. You achieve the mobility. You can, like I say, you can travel from location to location versus the service model, which we kind of went over a little bit. But the service model seems to have a much greater impact on the volume of foam that gets diverted, because in that process, you're taking it to the people. And it's a new process. Like I say, we've only had this out for a couple months, 3 months now. So I'm working with a lot of communities to work out the bugs out of what's going to be the optimal presentation. The common consensus is what we're calling pods. It's like carport-like structures put at a school, placed at schools, typically right off the parking lot because they need to get anchored down into the grass, but you want to have paved access to it where folks collect there. Then whether it's our service that comes and process it, or whether you have a unit in a trailer and go and process it, the material's processed right there on site. You don't have a line of trucks coming in and dumping to a centralized location. Next, please. Okay, and I do a lot of this because I enjoy this. I take these units to different city or different schools when we're talking about setting up recycling pods and programs. And I have to say, I really enjoy that, meeting with the science class and whatnot. These are just a couple pictures of doing that. Up in top there, you can see, and I did that to give you a visual, that a basic pickup truck load of waste EPS that would have went to the landfill becomes them logs. And as Gene alluded to earlier, we stack them logs on pallets, and then their end of life will become the beginning of life in a new product somewhere. In the lower left, you see exactly what the Styro Hybrid looks like. Fork truck or didn't ship it to you.
Hey, Brian, I think, I don't know if you can hear me, but I think we just ran into your internet. You there?
Yeah.
Okay, you cut off there for a minute. So talk about the hybrid unit again.
Oh, yeah. The picture there is the Styro Hybrid unit without a trailer, just sitting there. That one's getting ready to get packed up to ship out. But I want to kind of mention here, it's about 30 inches wide, about 67 inches long, and about 52 inches to the front of the chute. Trailer wise, you got to be a little over 6 foot once the lid's open. But that's an optimal setup for it, is to place that in, you bolt it down, screw it down in 4 places, and you have a recycling program as soon as it hits the trailer. Next, please. Okay, and this is just kind of a finish up here. That's who I am. This technology, I was pretty excited to receive the Recycling Association's Equipment Innovator of the Year, which kind of exciting. It was opportunity for me to go to Washington, D.C. and receive this award. So on my end, I enjoyed being recognized for it because it's taken me several years to perfect the process. But people don't see when new tech, and I'm a very small company, so when someone like myself innovates something like this, it's an all-in. It's much harder for me than a big company to do it. So I must say I enjoyed getting recognized, and that's my motto. My goal is to turn mountains of foam waste into molehills of reusable material, divert as much of it as possible from the landfills. Now, I'm going to go into one more thing. You'll run into, either way, you'll run into what people talk about as clean foam and dirty foam, dirty or contaminated. And dirty gets into a lot of the food and beverage containers. Now, I will say, I'll process all of it. There's no material, and then I'll wash the unit out once a week if I need to. But I'll run about any material that's at a collection site. And here's what I do. I actually set up 2 units in a trailer. I want one for the dirty stuff and one for the clean stuff. And by doing this, the clean stuff gets a new life and new product. It has a value. The dirty stuff, there's companies now that have the pyrolysis technology, and they're popping up all over the country. Well, they'll take that dirty material and break it down from a polymer to a monomer right back to its virgin form. It's an expensive process on their end, so it's on my end. There's not a value to it, but there's an extreme value with diverting it from the landfill. So there's no foam that I won't process when I get on site. And you're going to run into things like polyethylene, polypropylene. Well, we can run most of them too. Well, but we'll set that stuff aside and kind of run it separate too, because it's got a different recycle avenue. Is that the last slide, Gene?
Well, let me turn it over to here and let me start my video back up, and then I'm going to go into Q&A session here. Let me do this. Let me just, if anybody has a question, we can do this one of 2 ways. We can have you direct it through the chat, or if you want to, we can have you unmute and let you ask your question that way. If you want to, through your chat function, just let me know. You know, I've got one question for you, Brian. You said you put the equipment inside a closed trailer.
Yes.
How big of a trailer do you need? You said it had to be at least, what, 6 feet up?
Yeah, right. Ideal for me is about 10 feet long. And that gives me enough room to set a pallet on the tail end to stack the densified material.
And then how do you deal with the emissions from the from the motor, right?
Well, I'm glad you asked that. Well, there's 2 sets of emissions you're going to deal with when you're using a thermal densifier. You're going to have a fume, a toxic fume, I guess I should say, that comes off when you heat up a polystyrene. What I do to address that is the motor actually intakes directly off the densifier head. I don't smell nothing. I don't see nothing. And it's reburned to the engine with the oxygen in the air. Now, output wise, I have a traditional muffler on the bottom of the densifier that I route right out the floor of the trailer. So I get no smell, no emissions that I've ever noticed inside the trailer itself.
Okay, all right. Eduardo Garcia asked a question. What's the approximate cost per pound of processed foam on the mobile versus the stationary? And so maybe you can address the mobile side. What is the cost per pound if you've equated that?
Well, I can run, it depends on density, but I can run a minimum of 300 pounds on a gallon of fuel. That's a number that I'm pretty firm with. Now, the other variables is, you know, what's the unit itself? A standard unit runs about 20,000, or a little under actually. So, you know, you've got your operator cost, the unit, and a trailer. So, you know, you pick the trailer, whatever the labor cost is in your area for the operator. But from a energy standpoint, to operate the machine, you're about 300 pounds for a gallon of fuel.
How many pounds can you process in an hour?
The base unit will start out at 100. Now we can scale it up. That's an 8-horse. I can scale it up. The next one's a 12-horse, and we can almost double that. We'll hit like 180. Then I can scale it up again. So I can get, you know, use a number. Say you wanted to hit 300. Well, then I go with a twin cylinder engine and twin densifier screws, and each cylinder heats up each screw, and your capacity skyrockets.
Okay. On the service end of it, how does that work? I know you said you could go pretty much anywhere. I'm assuming that's in your locale.
Yeah.
Let's say somebody here in Florida wanted to. We actually have somebody online from Honduras. So just to give you an idea, that's one of the advantages of this. You know, these webinars is you're able to attract people from all over the place. So
well, Gene, you say that. I've got a unit that's servicing the Maldives Islands.
oh, okay.
They put it on a little boat, a little barge of some kind, and they mounted it to in actuality, I built running gear for it, kind of like you push a wheelbarrow, but they're running it behind some little ATV. So they drive it off, drive it up to a location, process all the foam, drive it right back on, and go to the next island.
Oh, I could see where this would be really, really valuable for the Caribbean, right? All right, so we got another question coming in. How large a cooler will this handle?
Well, my base unit has a 16-inch by 36-inch input chute.
Okay.
So you can throw anything in up to that size.
All right. And anything else over that, you'd have to break it down.
Correct. Well, but if you want to get up into higher values per hour too, then I'd scale up to, all right, let's make the chute opening a little larger, the shredders a little larger, because you want to be able to feed at a much faster pace. Because most people don't realize when you say you want a unit that will do 200 pounds an hour, 200 pounds of foam is a lot.
Yes.
I mean, it takes a couple guys humping to keep up with just feeding the machine.
Right.
And I don't know if you guys run into it, but we see it every day. Well, there's box tape, there's labels, there's each piece of foam, and I preach this, that do a visual on it before you throw it in there. We have run a metal drawer slide before that was just stuck, from the shipping. They had it taped to the bottom of the foam, and went in there and created havoc. So when you start getting up in high values, you can start figuring 2-3 guys just to have the material staged as you're feeding it.
All right. Let me ask this question, because you and I actually talked about this the other day. One of the concerns, or one of the questions that I got in advance of this webinar is, what do you deal with PVC foams? And I know you and I talked about it, but for the viewers that are listening, can you talk a little bit about that and how you recognize a PVC foam as opposed to, expanded polystyrene?
Well, yeah, and even further, you're going to run into a lot of different foams you'll have to recognize. Myself, after doing this so many years, I can pretty much look, feel, and know what that material is. There's no rule, a basic rule that I preach: if you can't break it, don't run it. Because then it's usually a polyethylene, or they're more rubberized. But something else that people don't realize, that the word styrofoam, is expanded polystyrene. We've covered that, but the wall insulation board is not common, like the 4x8 sheets you see on buildings, is not commonly recycled because it's an extruded polystyrene, not an expanded. You know, so for me, that gets classified as dirty, and I still run the stuff through there. But yeah, there's a trick, and I've got cheat sheets that I've made up to help customers identify this stuff because of what, like you said, like PVC is a very nasty material that you don't want to run. You know, it's got a toxicity to it that is not something you want to be exposed to. So yeah, that's another reason another reason we started the Styro America service. So you don't have to learn all them various materials. You know, one trained operator is the guy making that decision on the fly, and you know, everybody on here has probably been to a collection point and seen. I mean, I've seen rolled up that memory foam mattresses come in. So the sky's the limit on what you're going to see.
All right. So we've got a question here back from Eduardo asking, what is the highest density the mobile unit can process?
About 5 pounds is all I've ever ran, and it's set where the motor drives into the shredders. It's got a designed fail point, and it's just a 1/4-20 shear pin, and what that's for is in the field, like my example, where the metal drawer slide got thrown in there, it'll shear that pin, so it doesn't damage anything other than a 20-cent bolt. So if you're going to run a heavier density, then 4.5, 5 pounds, because that's getting pretty dense, then there's actually a different configuration that I would set up the shredder teeth. The shredder teeth are about a 2.5-inch tall claw. And if you go on my website, you can, on Brohn Tech website, there's some videos on there that shows you the shredders, and you can watch what they look like and what's happening. But for higher density, I changed the design of them teeth so they're not as aggressive, because that material just takes more torque to shred. And if you throw it in higher than that in a standard unit, it'll heavily shear the safety pin, thinking you've got something in there that doesn't belong.
All right, so you got a safety pin built into it, so you're not really going to stall the engine, which is another one of the questions that we got.
Well, that's just it, Gene. I have never, in it's 5 years now, stalled the engine.
Okay.
Not once, not any time. What I have done before the shear pin is rip the teeth right off the 1.5-inch gear.
Yeah.
It's got so much torque, and I explain a little bit why that is. That 8-horse motor is a motor that Honda builds. It's a custom setup where it's got a gear reduction built into it. The motor was originally designed to run stump grinders, tree shredders, cement mixers, things like that. So it's extremely high torque. So that motor is going to plow through anything that goes in there until it breaks something. But the motor never shuts off.
Okay. Talk a little bit about the extrusion end of it. When let's say you're processing and you're extruding out that densified EPS. When you go through, what do you do with the end product? So you're getting ready to close off for the day and shut your unit down. How do you clean that entire process out, and what are the steps and some of the lessons you've learned in this process?
Sure, it's taken years to achieve this, but it's a very simple process at this point. What I have, if you've ever been around anybody or anybody's seen anybody bale hay, well, it's similar to a hay hook. I've got a 3/8 piece of steel that's got a hook on it. So what happens is when the material is all ran out, right when I'm throwing in the very last of the material, I'll put the motor on an idle because I'm wanting to lower the head temperature. So I'll just let it sit there and just keep idling as it's cleaning out the hopper and cleaning out the screw. Then I'll grab, very similar to what you had in the slide up front where somebody was stacking that stuff on a pallet. They were basically winding it up. I don't wind it up. I run it in about 3 foot, 42-inch lengths, whatever my pallet is. and then I cut it while it's in operation. That cools off in a log form.
Okay.
But when I'm done, I grab that log and just put a constant pull on it. The material wants to stick to itself. So I will pull out probably 75% just pulling that log, and everything comes out with it. Then I take that hook and just stick it up in there, and once again, wear gloves because it's about 350 degrees, and clean out anything in there. And what I find is you'll find lots of stuff that you didn't realize went in there. You'll find, lots of box tape. Box tape melts at a higher temperature. So you'll see it in there. You can pull it out. Labels, paper labels and stuff. You'll find them in there. So, and then I'll go one step further then. So now you're on site and you're wanting to start, you've just cleaned it out. Next day comes around, you're ready to run it. You start it up, there's a temperature gauge on it and there's a tack on it. You let that temperature gauge hit to about 400 degrees, which is an internal temperature, not a surface temperature. You let it get warmed up, which will take you 3 to 4 minutes. It just depends on ambient temperature and how cold it was. And then throw in a handful of foam, because what you're wanting to do is get that head restuffed with foam because it's an insulator.
Right.
That accelerates then the densification process. That the head will climb in temperature very quickly, and I feed it in slow for a couple minutes. Just throw in shoebox size pieces just until I start seeing it come out. You can actually look in the head and watch the material shrinking when you're about at temperature. Now you know you can just start. And then once you start throwing it in there, keep the hopper completely full. Let the thing just sit there and, keep it fed, and you'll have a nice formed log where you don't want to have voids in it, because when it's coming out, it's cooling down quickly. That outer skin will cool quickly. So if you just keep throwing it in there where it's got a constant pressure, you can output some pretty logs, if you will. And I use what looks like a big steak knife, and right as it's coming out the head, I just cut it when I'm ready. Okay. The length I want, roll that over, and in a matter of a couple minutes, that's cooled off enough and hardened in that form.
Yeah, so you're doing the logs, putting on them onto pallets. I've seen other people with other plants, they were doing what basically a patty, if you will.
Yeah, oh yeah.
And do it that way, and then put that in a super sack. Talk a little bit about the market for the material. The companies that if you're comfortable with sharing who you send your end product to, or if you can maybe talk a little bit about the marketability of the material. And I might be able to chime in a little bit, because I do know some folks in the industry that will accept it.
Sure.
But you have a problem getting rid of the material?
No, the material is not hard to get rid of at all. Right now, where I'm located, because I'm not focused, I'm focused on the manufacturing of the equipment and the service model. But any material that we send to market goes through a local company here, which is Quincy Recycle. And they're in like 7 states. They'll take all of it I can produce. But, in different locations, I got to do a little research, because, for example, I got one that's just getting ready to go toward Nevada. Well, I don't know the market in Nevada. So I have to reach out to people and say, okay, is there injection molders there? What's the closest pyrolysis plant? What's the option of that? Because it's all about the shipping distance. If anybody's ever looked into it, there's a website called Home for Foam that's reasonably handy to give you options on buyers. I keep a database because I get contacted. The more these units and this service gets more popular, notoriety, the more companies that call me, we buy the material. Where you at? I'll put you in my database, because if a unit goes there, I want to be able to pass that information along. So, and that's ever changing.
Right.
But like I say, the biggest thing right now, and I follow a little bit, is and I'm sure there's companies your direction too, is like the Agilix companies and all the companies that do this pyrolysis.
Right. And those, as you've said, they are starting to pop up more and more.
Yeah.
Agilix is a little bit different in that they specifically are focusing on polystyrene in the conversion of that material. Let's go back to the service model aspect of it, because that intrigues me a little bit, and I'm sure some of the folks on the webinar would be intrigued in that as well. How does the service model work? Is that something that you've thought about franchising, or is it, you know, you could anybody could maybe get one of your units and turn that into you know, a business model for themselves to go out and provide this service in their area?
Well, absolutely, and that's my ideal goal. Do I want to run a franchise? No, because that's a different beast, and that's not where my passion's at. Owner operators to me is the best way to go. They can control everything. But what I'm trying to achieve, and something that's happened is I've been contacted by a couple now, big chain stores, and when they made first contact, Gene, I was obviously excited because they were over 1,000 stores nationwide each. I thought, holy cow, that's a couple thousand units. Well, they were interested 100% in the service side of it. Gotcha. And they went on to explain why, and it's just things I'd never thought of. For example, the one company said they have 300 corrugated balers, just in specific larger retail stores they have. And at any given time, half of them are broke down. And I said, well, why? He said, because, you know, things go in there by people that probably shouldn't be running our equipment, and it damages things. So they constantly fight that. He said, the last thing we want to do is bring in a piece of equipment that they can tear up. And I said, no, I mean, I get that, because once again, this is very specific. You got to have a little knowledge. You can't just grab somebody and say, go run the machine and have no idea what the different materials are out there. But that kind of months ago, well, 6 months ago probably, is what spurred on the original thinking of, this is probably going to be the biggest impact and biggest value in the recycling world, is to do it as a service. It's just so much easier. But when you say franchise, that's the first challenge to it. And this is the challenge I'm facing now, is like both of them companies would sign on right now for the service. Well, I can't be in Florida and California in the same day. So, and you don't have enough from day one to justify the equipment there. Right. So it's going to take a little time from that perspective to get more units out. But I would love to be able to send a unit, say, to your area and say, by the way, here's 3 accounts you can have right out of the gate. Right. You know, that's advantageous to everybody.
Do you charge, is your model to charge by the hour, or how do you do that right now?
Well, we've tossed around a lot of different directions, but the most feasible way to do it is to go into a community and base it off population. And for example, if I'll use right here, our system right now, we have the garbage sticker system. So it costs us about $1.50 to put a garbage sticker on a 33-gallon bag to throw it in the waste. It costs less than $1. I'm working on the details with a city of about 150,000 right now. And it got down to, it was like 87 cents. I say, okay, 87 cents per population. And we'll come in and set up 4 pods, and anybody in them areas can take their material there. So they're not paying to have it landfilled and have it hauled off. So that's, you know, and I push this, that's far cheaper than what it costs to landfill. And that's far cheaper than what it costs for 5 centuries of maintenance in that landfill. I mean, that's a huge number when people really start thinking about it. And if anybody's heard the super funds and things like that, you know, the more we can divert is minimizes the long-term liability, you know, for sending this stuff to the landfill. But like I was telling you the other day, Gene, in my mind, polystyrene should be the next tire, paint, electronic. It just shouldn't be allowed. And you know, it has to be mandated at some point, just like we did all those other products of, okay, let's recycle this. It's not acceptable to put it in the landfill. And I'm hoping in years to come that it gets that way, but that would be the best for the industry as a whole as well.
All right. Well, let me ask the final round of questions to everybody that's on the line. Otherwise, you can reach out to Brian directly. Our contact information is on this. Just to remind everybody, I will be sending out the video link that I'm recording right now. I'll get that uploaded and put it on our YouTube channel, as well as the presentation itself. I'll shoot the PDF and get that out to everybody. So one last time, if anybody has any questions, if I don't see anything, then I'm going to close this off. Brian, phenomenal. Thank you, sir. Very intriguing.
Thank you.
I wish you the best of luck. And I have a feeling you're going to get some work out of this here in the state of Florida, which is something that I think that we need. So again, thank you. And we'll close off for the day.
Thanks for having me, and thanks for everybody that attended.
All right. Thank you.